Good day to you, my dear friends. It's time to solve some LeetCode problems, yay. Unfortunately, I do not have a lot of time today. And it's very loud outside. But still, I need to solve something every day. But let's start with the problem that we solved like a week ago, I think. It was this: count nodes equal to average of sub 3. Of what do we do here? For example, we have not the best example. Yeah, maybe we have a better tree here somewhere. It's the same tree. Yeah. Well, we want to count, to sum the values of all the nodes, and then we want to find an average value. So we divide it by the number of nodes and we compare this number to the value of a parent node. Let's call it like that. So in this case, it's just this node, it's a final node, this one and this one. And what we want to do is I don't even remember, to count the nodes, right? Oh, wait. Oh, for this node also. You see, because 5 plus 6 is 11, we divide it by 2, we get 5 again. Well, when rounded. So 5, 2, and what else? And even for this node. That's interesting. So, as a final answer, we want to give the number of such nodes. I know it's a very hard explanation of this description, but you can read it by yourself, I hope. And originally I created this solution. Let me copy it. So for every node we look for a sum of all nodes to the left, sum of all nodes to the right, sum right, and the same for count. We want to know how many nodes we have to the left, how many nodes we have to the right, and then we combine all of it. So I created this recursion. We call this function again and again and again for left node and for right node, and as a result we get an array where we have a sum in this direction, a number of elements of nodes in this direction, and a result, how many nodes that satisfy this condition. Where is condition? This condition we have in this direction. And what do we give this method that we call again and again? Well, the node itself, like left node or right node, and result. But this was my mistake, because why do we need to send this result lower and lower and lower if it always equals to 0? Doesn't make much sense. So let's remove this second parameter and this argument here and here, of course. And we want to return not result, we want to return 0. So when we are at the deepest level, we start counting from 0. We do not need to send anything to the method because we don't even use it. So we have this solution. And of course we can just store everything we need. I don't know how to call it. Let's say left node data, something like this. And in sum we can just use 0, sum right again 0, but right node. And for this, let's call it right node data. Yep. Count is the element number 1 in our array. Result index 2. Just to get rid of all these extra variables, you know. Maybe it's not easy to read, but I like it more. Something like that. And if we look at the solutions section for Ruby, well, we have pretty much the similar solution. The only difference is that they move this recursion into another method, and they do not have to return result. They just store it in this global variable. And I do not like this approach only because it's 2 methods and not just 1. But of course my way have a downside too. We need to do this thing. We need to add this extra parameter, and based on it we want to decide what we want to return, this array or the result, like the final result for the first node in the tree. As for the other solutions, well, again it's the same, but using lambda functions in Ruby, but the logic is the same. We just move everything into this lambda function. It's nicer because, well, we have everything in just one method. But do we actually? I mean, it's also a function, but it's nice that we do not need this global variable. I like it. Next solution, what do we have here? We have a separate class, but it does exactly the same thing. Here we have a method for recursion, and in initialize we have this class variable. And again the same. I do not know why they use dollar here, but okay. Seems like an overkill. So pretty much it's the only way, and the only question is the number of methods that you want to have. And that's it for problem 2265, count nodes equal to average subtree. Now very fast, let's solve something new, and probably something easy because, well, I do not have time today, unfortunately. It's page number 5, I guess, or 6, I don't remember. Oh, we have everything solved. page number 5. How beautiful is that? Let's proceed to the next page. Yes, yesterday we solved this one. Now, what is this? Okay, substrings of size 3 with distinct characters. Ooh, a string is good if there are no repeated characters. Given a string S, here is one. Return the number of good substrings of length 3 in S. NBAB, ABC, and BCA. And the goods are where there are no repeated characters. So, okay, S length times do. Let's call it triple. Oh no. Let's not call it triple, it's a stupid name. Let's call it start index. So we start with 0 and probably it's not length. No, it's alright, it's length. Start with 0 and we want to if there is a character with index start index plus 2, we take this substring and that is S from start index to start index plus 2. Probably we do not need a variable for this. Let's see. We just want to check. Well, no, let's have a variable for now. And if let's do it a long way. No, of course, let's just brute force it. If sub characters unique length is 3, we gonna increase our count something like this. I mean, of course I hate doing this, but it's all green. still green, and time is good. Yeah, I guess this is not a problem because, you know, just 3 characters. It's a big O of 1. It doesn't get bigger with a bigger number of, with a bigger length of string. Memory is not that nice, or maybe not, who knows, but can we do something about it? We can do a one-liner, I think. Let's experiment. Jesus, I don't have time. But still. S characters. And each. Can we count with index? I forgot this. I forget this every time. Let's try. The same thing. Let's do element, not element, number and index. Oh, it's so slow today, I don't know why. I plus 2. And then we want to do s plus s I plus 1 plus s, not s. Well, here we have just num, and here we have s. Okay. Plus 1 plus s I plus 2. And we want to count number only if. We can't have this double if. No, we can. Why not? Why the hell not? If this and no, let's do like this, an array, and if this array unique length equals to 3, and it probably won't work at all. Okay, so we need to do each with index and then count. About the same. About the same. But it's a one-liner. Haha. Of course ugly, but that's the way we like them, right? I like my one-liners ugly. But I'm afraid that's it for today. It for today, it for today. And I'll see you tomorrow with new problems and some old problems, of course. Another problem solved. Goodbye, thank you very much, my imaginary viewers. Don't forget to subscribe, follow, and whatnot. People from YouTube, don't hesitate from following me on Twitch. Yeah. Thank you. Bye bye.